Hello everyone, Varuna here, and welcome to a KTaNE model module tutorial on the module Cruello, or Cruello, however you want to pronounce it. This module is absolute hell because it's a module that's been out for over 4 years and still does not have a proper solving method. The way it works is very similar to another module called Cruello. In this module, you are presented with a 6x6 grid of numbers that initially start out in the color magenta, but if you click them, as you can see, you can change their color between magenta, yellow, and cyan. The goal of this module is to have every number in a row to add up to the number, same with the columns, and also uh, have another rule uh, met, which is this, that if a display is white, there are 2 buttons of each color in that row or column. So since this display here in row 1 is white, that means that there has to be 2 magentas, 2 yellows, and 2 cyans in this row. If it is a different color, for example, magenta, yellow, or cyan, that means that the majority of the colors in that row or column have to be that color. To begin with, I'll note down the entire grid of colors. So 455, 366, 367, 265, 469, 304, 380, 909, 496, 334, 151261, and toggle each one. Then the same with yellow. And then the same with cyan. In 9952, 933, 959, 676, 547, 068, 955, 77, 6137. Now in this grid here that I have on my spreadsheet, I'll note down these displays. So 18, 38, 21, 22, 39, 11, 20, 26, 32, 24, 24, 23, as well as their colors, which these ones don't change. It's just these two that are magenta. I'll explain what these grids here do in just a moment. But so this grid here is the entire magenta grid. This is the yellow, this is the cyan. This is what I have so far. So I'll be noting down what digits I know have to be in certain positions here. This is the minimum table, which basically it takes the minimum of each position. So if I wanted to find the lowest value in, for example, delta 3, it just checks these values and gives the output. Same here with the maximum, which takes the highest value instead. These numbers here is just the sum of each row and column. It's the same here, here, and here. These two I'll explain while I'm in the process of solving the module. So a good place to begin with when trying to find out what to go for is to look at a row or column where the target number, the target sum, is closest to one of these values for the minimum or maximum. And I can see that this column here, this 17 and this 21, I have only a difference of 4. So this should be a good place to start off. And we can see that there has to be 2 magentas, 2 yellows, and 2 cyans in this column. And the way we're going to deduce what numbers have to go in each of these positions is by figuring out what it cannot be. So prime example should be, for example, this 7. let's say that this position had to be a 7, this Charlie 1. So we just remove these two, and suddenly we can see that the lowest possible value that we can get from this column is a 23, meaning that we will never be able to reach 21 if Charlie 1 were a 7, which means that we know this position cannot possibly be a 7. And that's where these two tables come into play. Here, when we compared this column and this column, we just compared these two numbers. And the way you can figure out whether or not a number is valid or not, or like whether or not there can be a solution with it, is by taking the difference between these two numbers and adding 1. If a number in one of these is pretty much is higher or lower depending on which table you use, or equal to that number, then it means that it cannot be that number. Let me find another example. Okay, here's the same thing, but with what is it? This Charlie 2. So in Charlie 2, we see that there's a 9 here somewhere. Yeah, there's a 9 in this position, but a 2 in this position. So, uh, we, how do I say this? If the difference between two of these positions is greater or equal to than the difference between this and this plus 1, then it means that it cannot be the higher value. Same thing if you're looking at the maximum table and comparing to the minimum table. So that's what this table does here. So we have that the difference between these two is a 7, and we see that the difference between these two plus 1 is a 5. Basically, what this table tells us is that if there's a value in this table that is higher or equal to this value here, we can just remove the highest value from this. So in Charlie 2, we can remove the highest value, which is this. Let's see this change to a 2. In this position here, Charlie 3, we could remove this 9. Because again, if it were this 9, the lowest value we could get is a 23. So not this 9. And now we see that this changed from a 6 to a 5. It still cannot be the high number. Again, if we tried this 3, if we tried this 8 as the position, the lowest possible value we could get is a 22. So we know it cannot be this. And now look, Charlie 3 cannot be magenta nor yellow, which means that it has to be cyan. So I'll mark that right now. I'll mark it in this table as well as highlighting the number here. It's a bit difficult for me to explain these tables here, but as long as you know how to write the formulas for them, which is extremely simple, you should be fine. Basically, with this table, you're looking for numbers that are equal to or higher than the number in that row or column. So that's this column cleared up with when comparing with the minimum. Now let's move to a different column. This column and this column are close to each other, only 4 apart, which you could see here with just the plus 1 turning into a 5. And now we're going to do the same thing, except now we use the maximum table instead of the minimum. This value is a 6, which is greater or equal to than 5. So let's see what's going on here. We see that there's a 0 here somewhere. Where is it? There's a 0 here and a 6 here. Let's say it were the 0. Then the highest possible value that we could get is a 36 instead of 38. again, meaning that we cannot use this 0 here. And you see this number change here after I remove a 0, like that. And we just do this process until we get the entire grid. And if you get stuck somewhere, you're just gonna have to guess. That's pretty much the whole gist of this. So we see here in Bravo 4 that the difference between these two is a 5. Meanwhile, the difference between these plus 1 is also 5. So we can remove whatever the low number is here, because again, we're using the maximum table here. So you can move this number. And also Bravo 6, we can remove the lowest number, like that. Okay, so that's that dealt with. Now we can move on to row 4. We can see that this is a pretty low number. Again, so an easy way to remember is that if you're using the minimum table, you're going to be removing the high numbers with it. If it's the maximum table, you're going to be removing low numbers with it. So here we have this 7, the difference of 7, which means I can remove this high number. And we can also remove this high number because it's still matching. And this is the 0, which means that there's only one digit here, this 2. And it's in yellow, I'm going to mark that. Now this delta 4, we can remove this high number, and also this high number, which means that it has to be the 0. You're not going to get this lucky with every case. Getting whites is probably the easiest case that you can have. Most of the time, it will just be mostly one of the same color, of magenta, yellow, or cyan. Which with that, it's a bit more difficult to deal with, but it's manageable. Let's see, is there anything else? This number is greater than this. So we can remove the high number from this. And that's it with this table for now. Now let's move to here. This 9 here. So again, we're using this table, so we're going to be removing the low numbers. So this number. Now it changed. And that's it for now. So at this point, if you look at any row or column, you'll see that all of the numbers are lower than the number in that row or column. So what do we do from this point? One of two options. One of them is the more safer one, which is to do the exact same thing, except try and check whether or not it can be the number that is still closest to this. So for example, row 2 here, there's this 6, which is awfully close to being a 7. So let's see the situation in this row. This 8. So let's say it were this 8 here. Row 2, if you take all the lowest numbers and add them up, you get 26, exactly what we would need. Now, this is where the color rule is useful, actually. So let's say let's just highlight all the colors that would be. So there would have to be an 8 here. There would have to be a 5 here. There would have to be a 2, a 5, a 6, and a 0. So this would require 3 numbers in yellow in row 2, which cannot be the solution, because as mentioned before, if a display is white, there are 2 buttons of each color in that row. Meaning that it cannot possibly be this 8, because we just checked if it can be with the 8. And now we just do this with most of the other ones. So we see that there are these 2 here. So let's see the situation here. This 9 is a high number. So let's check this and this. The lowest possible numbers 2, then 4, then 9, then 0, then 6, then 3. That require 3 from magenta. Again, not allowed. So it cannot be this 9. And the same with this one. This 7 is the high number. So let's check if it can be the 7. Again, 24 and 24, and those match. 2, 4, 5, 0, 6, 7. 2, 4, 5, 6, 7. That require 3 from yellow. Again, not allowed. Meaning that it cannot be the 7. Actually, another thing that you could do is just by checking again with the color rule. So, if we know that in this row there have to be 2 magentas, and so far we have an option between this and this, we know that it has to be one of these two, but not both or neither. So let's see what happens if we remove this 8 and force it to be this 3. If it were this 3, that would mean that it cannot be the yellow or the cyan in these positions. And let's see what happens here. The highest possible value then becomes this. Then we can use this table to remove the low number, which means it cannot be this number. And then we're left with a 50-50. Let's see what happens here. It would have to be these two numbers because, again, that have to be 2 cyans. And these 2 yellows. It works. So we found a row that we do have a solution for. However, we're not going to mark this as the actual solution because there can be multiple solutions in a row, and that's the scary part. If you get one row wrong, you are very likely to get something else wrong as well. So now let's check with it being this 8. So that I remove this and this. We see that the lowest possible value we can get is a 25, and we need a 24. Therefore, it cannot be this. Meaning that it cannot be this 8, meaning that it has to be this 3. We had this exact same case. We can remove the low number here because of this row that we had. These two are forced, and we're left with a solution. This is the actual solution in this row. So I have an 8 here, 4, 7, and 3. These are yellow. These are cyan. And this is the magenta. We did it. One row done. The module gets a lot easier once you're pretty much done with everything else, once you've filled out pretty much half of the grid. At that point, it's extremely easy. Now let's continue on with checking the numbers. This 7 and this 8. Let's check the situation here. There's this 9 and this 2. So let's say it were this 9. This was for the row. Yes. 24 here and 24 here. So let's see what it could be here. It would have to be this 0, this 6, this 5, this 9. Already we can see the 3 signs would have to be active. This, and this, which is false. We have to have actually most of these be magentas for it to be true. So it cannot be this 8. Oh wait, hold up. Did I do that correctly? Did I remove the correct ones? I checked these two. Yes, fat. 0, 6, 9. Okay, yeah, it can only be this 9. Let's ignore this for now because none of these numbers are close to the 8. This. Since we removed a lot of stuff from our certain rows, we see that this is now changed. So we can remove some more numbers from this, which are guaranteed to be removed. So it's this table that we're using, so we're going to be removing low numbers. which again, the difference between these two tables here, these numbers here, is that this takes a difference between the maximum table and the solution plus 1. This is the difference between the solution number and the lowest value plus 1. At the end, I'll show the formulas again so you could see how to make this spreadsheet yourself during a bomb, or even before a bomb if you're if you just want to practice. Let's see this. Yeah, we are on this. So we can safely remove the lowest number from this because, again, it cannot possibly be this. There's that. And then the lowest number from this position. There. Anything else? Not really. So we're gonna do the same process again. Can it be this this 6? That would force it to be 5, 6, 6. That's already wrong because there's 3 magentas in this. Therefore meaning that it cannot be this 6. Therefore it has to be this 9. It's the only position left. And again with power 3. Can it be this low number here? That would be 5, 9. I'm looking at this column right now, in case you're wondering. 5, 9, 3, 4, 9, 8. Valid solution, but is it the correct solution? Again, we can actually look at this here. We know that there has to be 2 signs in this column. Let's say it were this 6. That would mean that it cannot be this or this because this is forced to be it. Well, would be. Then the highest numbers would be, well, be forced to be 5, 9, 6, 4, 6, 8. Another valid solution. See, this is what you have to be careful for. Yeah. Oh, wait. No, never mind. Oh, yeah. This is another valid solution. So what we're going to do with that is absolutely nothing. We're just going to ignore it and move on with our day. We have this row. We're going to look at delta 3 here. This is the lowest number. So let's say it were this number. 20, is it? Oh, yeah, it's this row. Yeah, it would just have to be the higher numbers from this. So if, no wait, never mind. What am I doing? It's this row. So it would have to be a 9, a 6, a 3, then 1, 9, 4. Valid solution. Not necessarily the correct one. Anything else? Aha, yeah, this. This column here changed a lot since we last checked it. It's now at a 2 because we removed some numbers from here, I think. We're using this table, so I'm removing the high numbers. So it cannot possibly be this 5, and it cannot be this 4. It cannot be the high number here, and it cannot be the high number here. There you go. And now we're left with a 50-50. Charlie 1, the only position left here is this yellow. Charlie 2, it's the only thing that's left is this magenta. Charlie 3 is already checked with. Charlie 4 is already done. Charlie 5, because it'll be one of these two. Charlie 6 can still be one of these two. Actually, we can safely remove this 5 because we already have 2 yellows in here. Like that. And that forces this. uh, we can remove the high number here. And just like that, we see that the lowest and highest numbers match, which means that this and this are forced. 6 and 1. Magenta and cyan. What else could I check? None of these really help. I already checked that. This row. We can remove the high numbers from here. This high number. This is the high number. This is the high number. There. Now all of these are lower than that. Again, this row is a white, so let's check this, whether or not it can be the 7. That would force it to be this. Nope, it cannot be this. We checked if it can be the 7. If this position is a magenta, that means that it cannot be yellow. And suddenly the lowest possible value we can get is already above the target. Therefore meaning that it cannot be the 7. And there has to be 2 magentas in this row, meaning that it has to be this magenta here. Which means that it can be U or U, because that slot is already taken up by magenta. And look, we already see that it's forced to be these values here, because they're the highest values and add up to 26. So this position has to be a 5, and this position has to be that. There. Like that. 2 and 2. These two are cyan, this is yellow. Nothing else I can deduce from that. Yeah. Now this column is a bit more cleared up. We can see that these two are 6s. So I can remove the high numbers from here. U and U. And I see that these are 4s, which are still only a difference of 1 away from the 5. So let's check. In this case, it's actually going to be a bit more different. Because this column here is a magenta, which means that we cannot just say that, oh, it's this 4. We can remove these 2. No, because if a column is magenta, that means that there have to be 3 or more magentas in this column. So let's see. Let's say we're the cyan, because that would actually help out a lot. If it were the cyan, that would force it to be a 0 here and a 1 here, which means that there would be only 2 magentas in this column, which is false. We cannot have that, which means it cannot be this 5. Now let's check with this position. Actually, no, let's check with this position. Foxtrot 1. If it were this yellow, it would have to be this 0, this 3, and this one. So only be 2, again, only 2 positions in magenta. We cannot have that happen, which means it cannot be this yellow, meaning that it has to be the cyan. And now this is the interesting thing with these secondary colored columns and rows, is that if you get, for example, in this case, if we know that it has to be 3 or more magenta, majority of the colors here have to be magenta, and we already found out that 2 of these would be cyan, if we had more numbers to check through here, we would know that it cannot be any of them. Because with these columns, you can never have, for example, free cyan, free magenta. That will never happen in this module. Yeah. So did anything else clear up here? This position. let's say I were this 5. I would force it to be still this column would not have the amount of magentas we need, so it cannot be this 5. And now this clears up. We see that these and this match, so we can remove the low number from this. And this becomes a 1, which means that we have to take these values. So this 0, a 2, this 4, this 3, this 1, and this 1. So I have a 4 and a 1 here in magenta, and then a yellow here. Okay. What else can we check now? Not really here. Nothing here. Nothing here. Okay. I'm not sure if we checked already, but delta 3. We might have checked this already. Let's check Bravo 3 actually. Let's see if it can possibly be this low number here. That would mean that would have to be 5, 9, 3, 4, 9, 8. That is a possible solution. So let's see whether or not it can be this other number. If it were this here, I would force it to be this, which is the highest value then. 5, 9, 3, 4, 9, 8. Another valid solution. Okay. So there's 2 valid solutions in column 2. Not really much we can do there. Let's actually try and do echo 1. Echo 1 here. Let's see if it can be this low number. That would mean that it would have to be here in this column. 3, 6, 9. So already 2 yellows. 7, 7, 7. Though 3 of these yellows would have to be used, and we only have to have 2 in this column. So it cannot possibly be this 3. Yeah. What else can we check? Let's do this. Let's say in the first row, it were this one. That would mean that it couldn't be any of these 2, because we already have 2 cyans. And it cannot be these 2 because that saw would already be taken up. This value, the highest possible value that we could get from this row, is already below the target value, which means that, again, it cannot be this number here. Now let's do the same with this position. Let's remove this 8 and force it to be this. I mean, it could be these 2. Still a possible valid solution. But now let's use these. It would have to be not this, and would have to be not this. Valid solution. Let's try again with this position. So, I mean, it couldn't be this, which would then give us nothing from that. So let's ignore this row for now and come back to it later, because we know that row has only 1 solution so far, or perhaps a few. This 10 here is interesting to me. So we see that there's these 2 positions. We have a difference of 2. Not the best, but we can work with it. So let's say it were this 1 in this position. this and this. This row is a white, which means that only 2 magentas can be in this row. So if this magenta is active, which means that it cannot be these. That would then force what? What would it force? It would force this to be get removed, and it would actually, because of this, force this to get removed. Valid solution. Interesting. That. This. Yep, that's already on to the next thing. Yeah. Let's see. Let's try and okay. Let's say this position is a yellow. Just saying around a position. Then there can be any more yellows, and it can be these 2 positions. This value and this value, there's no solution with this set, meaning that it cannot be this 7. Let's do the same, but with this. Let's do this 4. This. Don't remove that. Actually, no. I'm pretty sure it would be easier. No, it wouldn't be. It would be 38, which would force a 4, 9, then 6, 4, 9, 6. 3 magentas. Cannot happen. Therefore, it cannot be this 4, which means that has to be this 8, because there has to be 2 yellows in that column. Yeah, these 2, which means it cannot be you. Does that help with anything in here? No. Actually, it helps with this. This position is forced to be a magenta, because we deduced that it cannot be cyan or yellow. Okay. Now it's just these 2 positions, and I believe this is just going to be a 50-50. Yeah, this is a 50-50, which means that it can be either a magenta here and a cyan here, or a cyan here and a magenta here. Both of these, 6 and 6, add up to 12, and 3 and 9 add up to 12. So in this case, you could take the 50-50 guess and then just work through your work your way through the module. And if you get it wrong, you just know it's the other case. Or you could just ignore it and try to look for something else. Like this. We know that it cannot be this high number here because of this 8, the difference. Let's say it would to be this 7. You've already checked that this magenta, with this magenta, you can have a possible solution. But what about the cyan? Would that mean that it cannot be these 2? And that leaves us with another 50-50? No. These 2, that, yes. So the solution then would be either having 2 yellows or 2 magentas. Because if we check here, this 7, this 8, this 1, and this 1 add up to if I can think, 17. 1, 1 plus that plus 7, yeah, 17. Which means that from these 2 positions, we would have to get a 6, which we cannot do because if it were both yellow, that would break the color rule. If it were both magenta, it would still break the color rule. Again, meaning that it cannot be this 7, so it has to be this 1. Um, 2 magentas already in here, so it cannot be these. Here, we can remove the low number. And because of this, we can remove the high number here. And just like that, we have everything here. 6 and 6. Oh wait, this is the cyan, this is the yellow. We can then check here, this column. We can remove the high number from this to lower this number here, like that. And look, this column has to have another cyan, and this is the only possible option. And this is a 1, which we have to take these values here. 8, 5, then 1, then 0, and then 2. 8, 5, 1, yeah, okay. Must be this 1 and this 2. Yellow and this magenta. This row already has 2 cyans, so we know it cannot be this. And we have to actually take the lowest values from this, because this is a 1. So you see here, at the very end, it gets way easier to figure out stuff, because we're pretty much done. We can use the help of other numbers that we have already to figure out other stuff. So you can safely remove this number here. And don't worry, if you think that like, oh, how am I supposed to know if this is with this table I'm supposed to remove high numbers or low numbers? If here you're supposed to remove the high number, in this case being the 4. If you remove the low number, this should go to negatives. Yeah. If you go into negatives, there's something wrong. So yeah. With that, you're kind of able to just figure out what number you're supposed to remove from what table. This position is forced to be a 0, and this position is forced to be a 6. Magenta and yellow. This column already has 2 yellows. Oh wait, no, we've already removed that. Yeah. Oh yeah, this is the 50-50. We can't do anything with that. This column here already has 2 yellows, so we can safely remove these 2. And we have to take the highest values. 0, 2, and 9. So we have to take this position. Then a 2, then 4. So that position. Cyan, and this is a magenta. This row already has 2 cyans, so it cannot be these 2. Let's take the highest values again, or actually just any values. Yeah, there. These 2 already. 9 and 6. This is a magenta. This is a yellow. This column already has 2 magenta, so it cannot be this. Meaning that it has to be the cyan. And then with this position here, I believe it's just the 7, right? This column, no wait, this column only has 2 yellows, so it cannot be you. It has to have a cyan, so it has to be you. There. 5. Now if we check everything again, all of these do add up to the correct number. All the rows and columns, as you can see, these all should match with this. And the colors, 2 cyans, 2 yellows, 2 magentas. These have majority magenta here. And yeah, that's it. So now we just input this onto the module. I'm going to start with the yellows actually. Here, here, and here. And then magentas, these positions. And then cyan should be in only those positions. And you submit with the top right button. And that is a solved Cruello module. I hope this tutorial helped. I'll show the formulas again. You don't really need to have these sums. You don't really use them much, but I just have them because of my OCD. So I'll quickly Control Z everything back until the beginning. Yeah. So these numbers here, you just input them as usual. These take the sum of everything. This is the grid that you basically note down with the module, what your current solution is. These numbers here take the lowest value from each of these positions. These rows and columns take the sum of every number in this table. Same with the maximum, just with the highest value instead of the lowest. And these positions take the difference between these two. You can actually just take the absolute difference. It'll be the same. Mike 13. Yeah, it's the exact same formula. And these columns and rows just take the difference, pretty much the absolute difference between those columns plus 1. So yeah, that's the end of this tutorial. If there's something that you don't understand, please leave it in the comments. I'll try my best to explain something that I didn't explain. Yeah, but other than that, that's this module. Yeah, I have nothing else to say. See you later.